Okay, so just a quick little wrap up here with horizontal asymptotes. If I'm to graph this question, see the difference now is I have a squared on my 2x in the numerator. So the degree of my numerator is equal to the degree of my denominator. The rest of the question would remain the same. X-intercepts, y-intercepts, vertical asymptotes, all that would be exactly the same. Obviously, the actual numbers might be different. For the vertical asymptote, would be unaffected, but the x and the y-intercepts might be affected because the question is different. What we're interested though is the horizontal asymptote, what happens in this situation. So if we take sort of the argument we made last time, and I've got a little bit more room to do it here. If I test a value in my expression, and I'll pick a nice easy one like 1,000, what I'm going to get for f at x is 2 times 1,000 squared minus 9 over 1,000 squared minus 6 times 1,000. Okay, so that's kind of what I'm going to get. And on top I've got 2 times 1,000,000 minus 9. On the bottom I've got 1,000,000 minus 6,000 minus 7. Following the same logic as last time, as I add more zeros in here, and more zeros in here, and more zeros in here, and I guess more zeros in here, this number gets significantly bigger. The 9 doesn't change at all. This number down here gets significantly bigger. The next one gets a little bit bigger. And again, the 7 doesn't change at all. And so what ends up happening is, as my numbers get big enough, this value becomes irrelevant, this value and this value become irrelevant. And we end up with 2 times whatever my x squared value was divided by my x squared value. And 2 times anything divided by that same thing again ends up giving us the value 2. So what happens basically is, if I see that I have the same degree here on my numerator and my denominator, and again it's the same largest degree, the largest degree is always the one that's going to matter the most with the horizontal asymptotes. What I can do is sort of ignore everything else and just kind of pay attention to what that specific boxed area is approaching. And clearly 2x squared divided by x squared is approaching the number 2. No matter how big x squared gets, it's the same on top and bottom. They divide each other out, and I'm left with a 2. So in this case, my horizontal asymptote would be the line y equals 2. The rest of the question would be done the same as it was. You draw in the horizontal asymptote, and then anything that's working above that would come down to approach it. Anything that's working below that would go up to approach it. Again, as we get to the outer edges, as we go to the negative 10 millions and 10 billions, and the 10 million and the positive 10 million, 10 billion, it is entirely possible that at some point throughout the rest of the graph, in the middle section, that line is crossed. Horizontal asymptote is only saying what happens as we get out to those extreme numbers. Again, vertical asymptote is the opposite, or is not the same at all. Vertical asymptote is an illegal mathematical operation going on, and so we never actually cross a vertical asymptote. Okay, so our 2 horizontal asymptotes at this point that we need to be concerned with, actually the only 2 horizontal asymptotes that there are. Numerator degree less than denominator, degree, you get a horizontal asymptote of 0. That is very poor writing. When we have the degrees are equal, the horizontal asymptote ends up being the coefficients of the numerator divided by the coefficient of the denominator. Okay, so again, we just look at the terms that we're interested in, the 2x squared and the x squared here, and simplify that. If it was something like again, just to go to the kind of the extreme cases here. If I had something like this, again, for my horizontal asymptote, all I'm really interested in is what is the top degree of each of the top and bottom. In the numerator, it's x cubed. In the denominator, it's x cubed. They are the same, and so my horizontal asymptote will be the line y equals 1/30 in this case.